Question is match the list 1 with list 2. List 1, the type of feedback is given, whereas in list 2, effect on R input and R output is given. In case of voltage series, what happens is we are taking the voltage from the output node, means that is a parallel connection which will decrease the output resistance, means R out decreases whereas series connection increases the input. Comes to B, R out decreases, shunt connection is also both are decreases. Comes to C, current series R out as well as R in both increases. Comes to D, current shunt means output increases but input decreases. Hence comes to voltage series means output decreases, input increases. So A is 1. Voltage shunt means both decreases, hence it is 3. Current series means both increases, hence option 2. Comes to D, current shunt means the remaining option 4. So A, B, C, D. 1, 3, 2, 4. Check the following diagram. Thevenin's voltage across VXY is. Suppose if we indicate this as VA, VXY is nothing but VThevenin's, which is nothing but VA plus 5. Here VA we can get it as VA minus 10 plus 10 divided by 5 plus VA minus 10 by 5 equals to 0. This is cancel. 2 VA minus 10 is 5. VA, here 2 VA minus 10 equals to 0. VA equals to 5 volts. Hence VThevenin is 10 volts. Hence option C is correct. Consider the following diagram. The load resistance to be connected across X and Y such that it dissipates maximum power. So in order to find out what resistance we need to be connected across XY in order to transfer the maximum power to that load, see, we have to convert the entire circuit into Thevenin's equivalent. So if we find out Thevenin's resistance, then we're going to know what resistance we need to be connected across the XY in order to transfer the maximum power. That is, RXY must be R Thevenin's for the above circuit. So we have to calculate the RThevenin's. In order to calculate the RThevenin's, we need to open the independent current source. We need to short the independent voltage source. Then we will get RThevenin's we will get as 7.5 ohms, which is option C is correct. The question is an abrupt silicon PN junction has Na 10 power 18 centimeter Q, 1 on side, and is 5 into 10 power 15 per centimeter cube, shown below at room temperature. We know that EF minus EIN is a positive number, that is KT, natural logarithm of ND by NI, which is equals to 0.329 electron volt. Whereas on P side, EIP minus EF is going to be a positive number, KT, natural logarithm of Na by Ni, which is a positive number, is equals to 0.467 electron volt. So hence option B is correct. Here the question is, an abrupt silicon PN junction has Na equals to 10 power 18 per centimeter cube on one side, Nd equals to 5 into 10 power 15 per centimeter cube, shown below at room temperature. We need to find out ECP minus ECN equals to, means which is nothing but a built-in potential, which is equals to KT, that is within natural logarithm of Na and D Ni square, which is equals to 0.796 electron volt. Hence option A is correct, that is 0.796. Question is, consider the following circuit. Assume large time constant RLC. Assume it is a silicon diode, means whose forward rope is 0.7. So when we if we look into the figure, it looks like a negative clamp, means it will shift the complete waveform towards a negative side, means The capacitor initially, the voltage across the capacitor is charged to 12 minus 0.7, which is 11.3. Means V0 is nothing but Vi minus Vc. So it is going to be minus 12 minus 11.3. When Vi is minus 12, that is minus 23.3. Hence option C is correct. Here we know that from the above circuits V0, Vi minus Vc is nothing but a V0. We know that Vc is nothing but 12 minus 0.7 is 11.3. Here when it is 12, Vi is plus 12, we will get 0.7. When Vi is minus 12, we will get minus 23.3. Hence the peak to peak swing is 24 volts. Hence option A is correct.